We are right at 2 o'clock, so I think we can go ahead and get started. I'm pleased to introduce today our webinar speaker, Dr. Lang Lee. Lang is the co-PI of the MPRINT Hub Data Knowledge Research Coordination Center, and he's going to talk to us today a little bit about the development of the knowledge base and portal components of the MPRINT Hub and the ability to have that available for use. So without further ado, I will pass it over to Lang. Thanks.
Thank you, Sarah. This is a, I would say, second time I present the knowledge base portal in the MPRINT community. We did it a few months ago in annual retreat, annual meeting. Then this time we're going to go over this again, but we have some more data analysis of the database. Okay, so the goal of our knowledge base is building up data, extracting data from literature, focusing on we're talking about 3 major study types: pharmacology, clinical pharmacology studies, usually describing drug exposure, which we call PK, pharmacokinetic study, and we're going to cover pharmacoepidemiology studies, and also clinical trials for maternal and pediatric patient population. And when we thought about early on, though, is we're trying to do manual data curation from literature and putting them in database. It is actually a very, very time-consuming process, and we're going to talk about in the second part of the database. We call it golden version. But even before reaching the golden version, I want to talk about a silver version database where, as a matter of fact, when we proposed our grant a couple of years ago, we didn't thought about this because we feel the machine learning approach may not be good enough or accurate enough to pull the data from literature into the database automatically with sufficient accuracy. But after quite extensive research using big language model, which I'm going to talk about, is called BERT model, we find that some of the performance of the BERT model is really, really good. Therefore, they give us a really good opportunity to pull, I think, all the data from literature into a database. We call it a silver version of database automatically. Okay. The major difference between silver version of database and golden version database we can outline later, but nevertheless, you can understand that the data we can extract from the literature in the silver database is probably not as deep we wish for, but at least give the audience a broader view of maternal and the pediatric area where how the pharmacology research is being carried out. Okay, so in the first part of the introduction, I will introduce the BERT model, which is big language model first, and tell you its performance. Then I'll show you the data in the database, and I think towards the end we'll do a simple data analysis on the BPCA list, which I'll show you later. Okay. For people who actually don't really know the BERT model, it is actually called bidirectional encoder representation from transformer. Transformer is a large-scale language model where it has 2 part of the models. One is input layer, the other one's output layer. Okay, and you can see the input layer, output layer has many similarities. Technically, it is using the called multi-head attention mechanism, where looking at all the data, language data we're trying to use the correlation, global correlation among all those words, languages, and trying to build up the relationship among them. Okay, so technically, the input model here is really not necessarily supervised approach. Is really unsupervised approach, trying to identify all the relevant data elements and trying to use that to represent the language, right? And output has very similar, we call it mirror imaging of input model of transformer. And then, but in terms of the data output though, it will simplify the model, then generate the prediction afterwards, okay? And there's a magic number here called N, means that, in the implementation side, there will be multiple encoders, okay? So technically in our exercise here, we're only using 12 layer of encoder, but in the reality, the encoder can go all the way above hundreds of encoder. I mean, the more encoder you have, the better the model can represent the language of the data we're using for classification. But nevertheless, most of our work actually is done by an encoder process, trying to represent our text as close as possible. Okay, and this slide still very, very abstract, means that it doesn't mean anything to you. Maybe for people who don't really don't know how this is going to work. So I give you another slide to tell you how it's really working. So technically, we can starting from a sentences from say abstract or title of the paper, and so the text goes as the purpose of this work is to compare efficacy of propofol blah 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 intubation such there could be multiple sentences over there, right? Then the first step is we typically transform this data elements, all the words into tokens. Okay, they call it token ID. So basically, we digitize every one of those words into a numerical number. Then we can pre-train with BERT model. In this case, we can train them encode 1, 2, 3 all the way to the 12. And all the different encoders actually representing different types of relationships. We call it semantic relationship among the sentences. And then the output though is technically a representation of the language based on the machine. Okay, so you can envision that the embedding here will be representation of a grammatic relationship about the sentence, within a sentence, between sentences, so on and so forth. Obviously, the more encoder you have, the more sophisticated model we're going to have to capture all the sophisticated relationship within the language. Okay, so that's all about the BERT model for the pre-trained BERT model. Then we're using pre-trained BERT model to do the prediction. So we do have our own training data, which is about 1,269 abstract related to drug research, 143 of them PK, 337 PE, and 171 clinical trials. And then there's another 650 negative papers, which doesn't belong to all three of them in our training data. And we try this three type of model: supporting medical machine, BERT model, and also BERT-T model, which is we say in this case we actually later on find out though is some of the labeling we did in the database when we try to create a training data, the labeling were not fully accurate. So we went back to the labeling process and confirm all the labeling, and that actually lead a better performance model. Okay. In terms of a performance matrix, we're talking about the precision, recall, and F1 score. The precision is the fraction of true abstracts among the predicted true abstracts. The recall is the fraction of predicted true abstract among true abstracts. Okay, so that's where two major matrix to measure the performance of the machine learning models typically. And F1 score is typically the average of those two numbers. Okay. So we did a classification of PK propagation versus none, and the performance, you can see y-axis though is the precision can go all the way to the 100%, and the recall can get close to 95%, and the F1 score is probably 97%. Okay. For clinical trials, again, the precision reached 100%, and the recall reached about 97%. F1 score is pretty high as well. Okay, and for the pharmacoepidemiology study, we have very high 100%. Precision recall is close to 95%. And F1 score is about 98% Okay, so that's where this data gives us a lot of confidence where the machine learning approach can really give us a lot of accurate data through the text mining of PubMed literature directly. So that's where when we applied this machine learning analysis to all the PubMed abstract, so we end up with 87,000 abstract in total, and among maternal publications, 33,782, pediatric publications, 77,286. Okay, and these are the distributions of 3 types of studies in the maternal population. Obviously, from EP study has more than the other 2 study type. And then for the pediatric publications, we have a similar trend, means that the pharmaco-EP study has more papers than pharmacokinetics and the clinical trials. Okay. Then we also look into how many drugs being studied in the literature. Totally, we have 2,643 drugs. In this case, we're talking both drugs and supplements. Right now in current version, we included both. But in our recent revision of the database, we're probably going to remove a fraction of the supplements if it is not necessary prescribed by the physicians. We tend to exclude them for now. Okay. So that's what it is look like in the maternal subpopulations. How many publications we're going to have? There, obviously, you see that we have 1, 2, 3, 4, 5, tackling the 4 different age groups in the pregnant women, and there's also pregnant in general, which is not necessarily can be categorized by the data analysis. But nevertheless, we have maternal, mother, and lactation, breastfeeding, nursing, postmortem, labor, and delivery. Okay, so that's where the distribution of the publication among different maternal subpopulations. Then we also did some kind of analysis, say how many distribution drug specific publications frequency. So the first bar is how many drugs with more than 1,000 publications, and the last bar means that how many drugs with only 1 to 9 publications. Okay, so this figure is really showing that there's significant fraction of the drugs is only studied very limitedly in the maternal patient population. Okay, well, so this is another figure showing the top 10 most published drugs in the maternal population. And interestingly, there's one drug, atezolizumab, where it has more than, I would say, 16,000 publications among the maternal population. It's amazing how much this drug has been studied in the maternal population. Actually, you can see the same trend in the pediatric population as well. So this figure really showing that we call a knowledge gap in maternal drug research. When I say knowledge gap, means that we certainly expect hopefully every drug being studied in a PK, epidemiology studies, clinical trials, because that's how drugs should be studied in all aspects of the drug research. And then technically, we saw that 862 drugs, they being studied on 3 types of clinical relevant studies. Okay. However, there are obviously other drugs, like 263 drugs. We saw PK and PE study, but we don't see clinical trials. 117 drugs we see PK study, clinical trials, but we don't see enough epidemiology study. Okay, and towards the end, though, for example, there are 245 drugs. We only see PK study, but we don't see clinical trials, epidemiology study, so on and so forth. Okay, so this figure is really showing you what are the gaps for drug studies among the drugs we have seen so far from literature. Okay, and this is the similar analysis for pediatric subpopulation, and we look at pediatric in general. There's child, there's newborn, neonates, preterm, and fetal. Okay, so that's where and most of those analysis frequencies based on the keywords presented in the abstract. Okay, very similar data analysis was done for drug-specific publication frequency. Again, in this case, we have 21 drugs, publication frequency over 1,000, and we have, we do have another 1,177 drugs. Their publication is around 1 to 9. Okay, so those drugs are not very well studied. Again, we list the top 10 most published drugs. Again, you see the artesunate has pretty significant amount of publication in the literature in the pediatric population. Okay, and then note those 8 out of the 10 top drugs overlap between maternal and pediatric populations. So it means that there's a strong connection between maternal and the pediatric pharmacology research in general. Okay, and this one is really a similar we call a knowledge gap analysis in pediatric drug publications. And towards the end, though, it's like, there are 140 drugs. We only have PK study, no epidemiology, no clinical trials. 182 drugs, we only have PE studies, but no PK and no clinical trials. And 89 drugs, we have clinical trials, but no PE and no PK. Right, so these are kind of data elements can show there are significant amount of knowledge gap for many drugs in the pediatric patient population. Okay, so this is a kind of a high level MPRINT knowledge base sealed version. If you go to the database, it shows you the distribution frequency of from PK study, epidemiology study, and clinical trials, and also show you the frequency of those drugs on the different patient populations. Okay, and obviously you can search for drug names, and if you type in the methotrexate related publication, the database is going to show you common ID, title, study type, population, and the drug. And you can see sometimes a paper has many different drugs simply because that's how study typically be done. Okay, and there's also a scenario a paper has both clinical trial data and the epidemiology data, because sometimes they do overlap. Okay, and population wise, there's also one paper can come from multiple studies, so that's where many times you see multiple populations as well. Okay, and the other thing though, you can also filter the query based on the population category. You can zoom in a little bit further as well. Okay, all right, so so the question number one though is what's the utility can be used, how this database can be used for clinical research. So one thing we saw a lot about this though is, how do we help the best pharmaceutical for Children Act BCPA list, because in this list, the most recent version is 2020, we have 157 drugs in 17 disease areas. Okay, and those are disease areas. Actually, there's 17 tables from the website. You can download it, and in which each table actually asks for potential evidence. Some of our PK, some could be clinical evidence of drug toxicity and dosing related questions, right? So what we have done trying to address this, not necessarily to address the question, trying to find out how do we use the database to help answer potential some of the questions. So we decided to look at the frequency of drugs listed in the BPCA list since 2019 by study type, okay? The reason we use a cutoff from 2019 though, because we saw the 2020 BPCA list, maybe say the federal agency may already review the data before 2019, then they make that decision that 157 drugs are important to do after 2019. So we're looking for the new data elements after 2019 to see whether the publication numbers are big enough, therefore we can make some prioritization. So we have done query on those 157 drugs in our database. We find there are 1,150 PK related studies and 3,726 PE studies, and there's 1,374 clinical trials. Okay, and the distribution of publication, the drugs, 157 drugs, are not necessarily balanced. Okay, you see a lot of there are many drugs, the publication above 100. Obviously there's one drug, nitroglycerin, right? Its publication is above 500. So those are very interesting evidence where I think some, among those 157 drugs in the BPCA list, some drug may deserve much, time to study to make sure, whether those published evidence are adequate to help resolve the questions, answer the questions on the BPCA list. And then obviously there's a lot of drugs, their frequency is very, very small. Many times below, 10 papers, maybe even 5 papers being published since then, since 2019. Maybe those drugs may not be, the evidence for those drugs may not be accurate for us to move on or study to change, to answer the question of the BPCA list. Okay, so anyway, so these are the ongoing effort trying to use the database to answer the question from BPCA, and we're still working on that. Okay, but nevertheless, this figure showing you how this data in a silver version database can be utilized to help explore the prioritization in the BPCA list. Okay. All right, so this is kind of a high-level overview of the knowledge base in the silver version. So in the meantime, we also spend a lot of effort focusing on the golden version of the database. The golden version database largely is a menu curation process where we have to define ontology, we have to define the data elements extract from different studies, then we have to do the menu curation. Okay, so this is where we're gonna show you step by step how we did it. So to begin with, we need to focus on ontology, means that how do we determine the variables, define variables in the clinical PK studies, clinical trials, pharmacoepi studies. Actually, we're focusing on drug names, outcomes, risk factors, sample types, study design, and statistics. And finally, we also are looking into the predictive model as well. Okay. And when we trying to build a MPRINT knowledge base, we did a PubMed search using a keywords. So this is kind of a keywords we have done so far. And we also did some exclusion criteria. No animal study, no reviews, no medication frequency or pattern of use, drug studies, no study where drug of interest is one of the major risk factor. Or if the full text is not available, we basically cannot get the data. So that's where the major exclusion criteria when we do the data extraction. Curation process though, in this case, we focusing on the PK study and a PE study. Okay. For the PK study, we have additional inclusion criteria. So single drug PK, drug interaction PK, clinical studies, non-conforming model, individual or summary data value for PK parameters. We don't do PBK model. I think this is where the modeling pharmacometrics core is gonna try and achieve. Obviously, we will only focus on the language is English. For the PE and clinical trial studies, we have including the drug exposure and outcome perspective respect study, quantitative data, pharmacodynamics, pharmacogenetic study are also included, but we are not including patient hospital usability study, patient provider engagement study, data mining of a registry or health records or case reports. So that's where we're trying to be differentiated what's happening in the so those data are not really included in our PE and clinical trial studies. Okay. In the PK data elements, so we have summary level data, including summary stats or p-values. If we do a comparison, population data, drug information, including dose, duration, dose delivery, interval. We also collecting the specimen information, including sampling information, time to sampling from those PK parameters and PD outcome as well. Okay. Then if the patient sample level data is available, we're going to collect the patient sample level data, multiple patients or samples per patients when available for any section data elements. Okay. And the details captured in section, including pregnancy stage, population involved, sample size, specimen type for each PK parameters. Okay. For epidemiology and clinical trials, we focusing on summary level data on association between exposure and outcome. Okay. And study information, we typically include study design, data sources, inclusion, exclusion criteria for the PE and clinical trials. We include sample size, outcome list, and the definition. Like PK, we also include population type, including pregnancy stage, drug names, classes. Okay. Outcome related parameters, we are including risk factors, drug exposure information, outcome names, and also summary variability stats and p-value. Okay. So so in the PK study, in this case, we're actually focusing on, in this particular data creation exercise, we're focusing on the opioids drug class. So in this study, we have, database right now has like maternal, non-pregnant adults, pediatric, fetal, preterm, newborn, neonates, infant, children, adolescents. Okay. For PK data, if we divided pregnancy stage, though, go from pregnancy, trimester 1 to 3, labor, delivery, postmortem, lactation. Okay. Then this is opioid drugs we curated for so far, and this is a parent drug and metabolites, the frequency of parent drug metabolites in the database, and these are single drug, multiple drug in the database. Okay. Sometimes the drug names is not specified because oftentimes when people publish opioids related the PK study, people just say opioids. It just didn't speculate what they are, right? In a study to some extent. Then there's also a specimen information in the PK study, including maternal plasma, non-pregnant adult plasma, pediatric plasma, umbilical vein, umbilical artery, cord blood, breast milk, placenta, urine, meconium, and the others. Okay, so there's quite a bit of diversity of the PK specimen in the database. Then PK sampling is also interesting data points, including there are case only study, there's crossover study, there's intensive sampling, there's also specimen sampling, okay, across multiple data types. And we first categorize them into maternal, non-pregnant women and pediatric patients, okay. So this is very interesting slides where what are type of PK parameters we're collecting in the database. You can also see some diversity over there. The most often reported PK parameters in the paper are by concentration, AUC, half-life, clearance, right? So those are very, very typical reported. Then we also saw published Tmax, volume distribution, fetal maternal ratio with the drug, and the milk plasma ratio and the infant dose. Okay, so these are some of them are calculated, infant dose, technically calculated numbers. So those are very interesting observation how PK parameter be presented in the literature. The PK endpoints, in this case we're talking about is the clinical endpoints of PK study in opioid related publications. Because sometimes they do, okay, and you know the most popular one is APGAR score and opioid side effects. They sometimes go side by side, so that's how we see it from the literature. And this is a epidemiology and clinical trial studies. Again. Population distribution among the curated data elements. Some of the categories are general because they don't further categorize what are the real patient population. Sometimes, you know, for example, 400 pediatric population, technically, many of those publications has a wide range of subheavy population within one publication, okay. If you want to see the pregnancy stage across publication, these is the distribution for PK, pharmacoepidemiology clinical trial studies, okay. And you know the most frequent one is post-bottom one, and the pregnancy in itself is a vague definition technically because it can cover all of them in the study. Then if you ask what's the distribution of study type or the design of those studies, you can see a lot of them are epidemiology study, some of them are controlled clinical trials, and then there's a little bit of genetics, a little bit of dynamics, and sometimes the RP study come from randomized clinical trial population. All right, so that's the major description of the study type of the design. Then if you say how design being carried out, you know, they obviously very majority of them retrospective study, some of the prospective study, and there's some randomized clinical trials. I think most of clinical trial data are, you know, clinical trial studies from randomized clinical trial design, okay. Then there's also observational study. It can be either retrospective or can be prospective. Sometimes they don't say very clearly what they are, okay. Then, you know, crossover, cross-sectional, longitudinal studies. Those are kind of a different study types in our database. And these are the opioids drugs in the P and CT study. Methadone is probably the most popular one. And those are the risk factors being studied in those P and clinical trials among those opioid medications. You know, you can see there's demographics, comorbidities. There's also social determinants information, genetics too. So there's also smoking, sex, gender, and the other substance, drug use, so on and so forth. Then outcome of the PE and clinical trials, there are maternal related outcome, such as breastfeeding, maternal mobility, mortality. There's also birth outcome, including EBGO score, birth defects, so on and so forth. There are also pediatric outcome, including hemorrhage and neurodevelopment. There are many cases, developmental questions in the pediatric patient population. Then there's also opioid related outcome in the study. This is where we kind of categorize them into opioids dedicated outcomes. And then there's also healthcare utilization outcome as well. Even though this is, in our early setting, we didn't intentionally use it as one subcategory, but there's still a lot of paper combining the opioid-related outcome and healthcare utilization outcome all together for the opioid-related drug studies. Okay, so this is kind of a cloud, figure where how do we see the outcome data in the pediatric maternal patient populations in opioid study. Okay. All right, so this is a screenshots on golden version of database. Very similar to the silver version of database. The first page gives you the overview of the PK and the PE study, and it layout by the different patient populations. And this is kind of if you zoom into the database and check the methadone, you're gonna see a lot of data related to methadone in terms of PK data. In this case, is PK data. Then there's also potentially PE information as well. This is largely PK data. Sorry. Okay. So anyway, so this is a summary of what we have done so far. So for the next step, though, is we're gonna focus on 86,000 paper data curation. So that's the major task for us. And we're gonna focus on drug with knowledge gaps, and we're gonna look into the BPCLS and see how the data curation can really help the drug prioritization for pediatric patient population. And we're also in the middle of formalize the prioritization strategy for maternal population as well. Okay. Then, I think right now the database give you the summary stats. The silver version wise give you a very high level summary of how's drug studies being carried out. Golden version of the database give you the data elements, right? But technically, it's really not necessarily very user friendly, or in terms of if we really want to know what study being studied, how this drug being studied in the literature, you want a little bit more high level summary of what has been done. So that's where we are thinking about how do we integrate the ChatGPT functionality plus information extraction all together and give the reader a little bit more first-handed summary of how study being done. So this is kind of an informatics AI developments from the database, and we're not there yet, but we're going towards that direction. And hopefully the knowledge base can also provide question and answer function where allow users to zoom into the data, huge database where we can get some pinpoint answer from the data we have in the database. Okay, so the second point is rather is informatics exercise, and we're trying to zoom into more concrete information to the reader. Then we still need to do a lot of data standardization. I think there's a major challenge where when people writing the papers, how do they write the clinical outcomes and risk factors? There's people not using dictionaries to do it. People using their own language to do it. So there's a huge variation of how clinical outcomes and risk factor being presented in the literature. So therefore, if we really want to integrate the data from multiple publication sources, we have to figure out a way for data standardization. Right now, we're not totally there yet. Okay. And the drug as supplements. This is kind of a major challenge where there are supplements that are also used in the clinic, pediatric and maternal setting as drugs to treat certain diseases. So that boundary is not very clear, right? Even when we look at different databases, especially drug databases, the boundary is very vague. So this is where we need to do a bit more work in terms of data standardization. How do we differentiate them? So this is an ongoing exercise. Take a lot of effort from our team. All right, so this is the knowledge portal links we have. We're going to share with everybody, and you can go in and try the database. Finally, I want to acknowledge it's a strong collaboration between our team from Ohio State University and Sarah Quinney from the Indiana University, who's in charge of the pharmacometrics core. So I think this is without very close interaction between two groups, there's no way we can get this stage. The development portal, knowledge portal is by Dr. Lei Wang. He did most of the work building out the knowledge base. And the knowledge base design and curation is carried out by Aditi, myself, and Xiaofu. We have several well-established data curators, including Dashini, Sam, and Shijun. I think that's all I have today. I think people may have questions. I'm trying to save some time for questions. Okay.
Great. So thanks, Lang. If you have questions, feel free to enter them in the Q&A, or you can raise your hand and we can promote you so you can ask your question or participate in a discussion with Lang. So we do have one question that's already come in. Can you comment on how the ontologies you are using for age and pregnancy stage, as well as disease, are interoperable with other disease and age ontological frameworks?
Yeah, I think Aaron brought out this question. We do have a we call it ontology, especially different populations in the database. For example, say maternal has several and let me go back, and maybe that's a better way to do this. Let's stop here a little bit. So we do have, this is kind of high level representation of pregnancy, postpartum lactation, and for pediatric to fetal, preterm, neonates, and infants, right? But in the implementation side, though, there are a lot of different ways to say neonates or neonate. So we have a so-called dictionaries for every little word, okay? And then when we do the we call it entity recognition, which is kind of a natural language word. We're using that dictionary to match the presentations in the abstract to make sure it's a subpopulation. Okay, but having said that, again, it's an informatics analysis. There could be some measurement error, I'm not saying it's going to be 100% accurate, but that's how we using terminology, build up terminology beforehand. Then we match, we do the entity recognition in the abstract and use that to define a subpopulation. So that's how the oncology working with the paper classification. So that's how it is. I'm not sure whether I answered it in the right way or not. Aaron has raised her hand. Aaron, can you speak up?
All right, can you hear me?
Yes, yes.
Yeah, so I'm not as familiar with the age portion of this, but in terms of disease, and I'll drop a link in the question box. My question was more about, like, I'll say downstream compatibility or interoperability, and how people may eventually down the road start to combine MPRINT knowledge with other databases. And I put in the Mondo disease ontology from the Monarch initiative, which is an interoperability thing. So sort of what I'm getting at is, how is your framework either compatible or interoperable with the larger data ecosystem in the world, or how do you head toward that? So eventually, eventually thinking about how people will combine the data sets or do combined queries to link the very excellent work you're doing with the very excellent work that others are doing.
Yeah, really great question, Aaron. You're spot on the challenge. So right now we're not there yet for the disease outcome, I think largely there are several things, right? Number one is disease. Number two is adverse drug events. They are not the same, and they have different dictionaries. Like typically, for in the clinical setting, ICD-9, ICD-10, those terminologies are people use it for defining disease. But if you're looking at adverse drug events, people using MedDrug to do it. Okay, so we probably gonna go from there first. ICD-9, ICD-10, not at the code, but the word description of the ICD-9 code to start with for the disease. Then for the risk, for the adverse drug events, we're gonna go from the MedDrug. Okay, so that will be a starting point of the standardization. Then we're gonna move on. Maybe work with MASH as well, because MASH is the founding block of PubMed. Then it has drug names, it has all the other terms as well. So that's where we're going to start from. Then we're going to work with the other communities, trying to build up a little bit more kind of integration. But at this stage, though, we're not totally there yet. I think we have not yet really done too much about the disease name standardization yet.
Great answer. Thank you.
I think there's a similar question in the chat relating to using some generic terminology such as preterm and how that would be described. And I think so the comment is, for an obstetrician to use the portal, there needs to be clarity on how preterm is defined for the purpose of data collection. And I think one of the issues we actually see is that the definitions change across time and depending on where you're at. And so sometimes it's not always clearly defined in a manuscript either. So I don't know if you have any further comments on that from your experience, Lang.
Can you repeat the question, Sarah?
So how do you just define, so for some of the variables, you showed that, like pediatrics is a very wide variable. But, again, something like preterm could have various definitions. So when you're obtaining the data, are there more finite definitions in the databases for those?
I see. Sarah, the challenge of publication, though, is that if they define the preterm in the paper, we'll catch it. If they don't say anything about the preterm in the paper, we can't. So that's how it is. My point is, we can only catch what they publish. You got it? Then there's some variation, based sometimes they do have very detailed definition of what's the age group for preterm in the paper, or they have citation on that. So we'll get it. But if it is not defined at all in the paper, then we're going to miss it out. Okay.
Right. I would assume from a phenotype or disease state standpoint, it's very similar, where a disease definition such as preeclampsia, the definition changed a few years ago. So you would only be able to provide the information that was given in that article at the time being, not necessarily comparing direct studies.
Correct. So I fully agree. I think, there is a variation, is especially paper published in the different years. They may not talk about the same thing,
And then a second question. So in your analysis of the pediatric data, you only looked at publications since 2019. Have you looked at any
Not yet.
before that?
That's a really good, no, that's a really good question. So the point we put the 19 as a cutoff though is based on assumption though, as when people say when funding, when agency look at their data, I'm assuming they have, we make it strong assumptions, some assumption that they have looked at the data before that time point already, then they decided the data is not good enough. That's why the drugs has not been updated yet. So that's a major assumption. Okay. So that's where we say, okay, let's look at it, the data after 2019 first and see if there's any new data to help. If not, then we still can go back and see whether old data can help us, right? So it's a kind of a shooting for the low-hanging fruit. Doesn't mean we should not look in the 2019 data. I think we should. In order to make a final decision, I think somehow we have to include everything. But for this exercise, I think we just hope for the new data can really help us. So that's the major assumption over there. Yeah. So I also want to point out a couple of things. The silver version database. After we publish the silver version database, I think we also looking back and see there's still a lot of variation. I would say noise in the data. I think largely because there are overlapping populations. For example, one paper can talk about multiple populations, right? And sometimes the dedicated population study in that paper is not necessarily very well represented. Means that maybe the absence they mention a little bit about pediatrics, but the bulk of the paper is talking about maternal patients. Then in that case, the abstract may be mislabeled whatsoever, because that's where the machine learning is not smart enough to differentiate those kind of subtle difference. So that's where, if you go into the database, you may see a situation where if you look at pediatric drugs, but there's a lot of maternal related publications, doesn't mean this paper is totally not relevant. Simply means that this abstract may contain a few pediatric related terms. So that's how it is. And right now we don't have a good way to really differentiate, which one's which. And we tend to include all of the possible papers into that because we don't want to miss anybody, right? We don't want to miss a paper. So that's the one challenge we have not yet fully resolved yet. So that's the one thing I feel the silver version database, even though it's quite comprehensive, but there's still quite a bit of noise in the database. So that's one thing. Just for people who want to use the database, people should pay attention.
So Lang, is there, we have a little bit of time left. We've had a request that you pull up the silver version of the database, and I actually have it up if you want me to, or if you can go through it there.
Yeah,
I'll show.
Yeah, Sarah, can you show maybe?
Yeah.
Did I stop sharing?
Yep.
Okay.
You get to the right screen here. So one thing I was going to mention was that there is a place here in the about to provide user feedback. So as you're using the database, please provide feedback for it as well. For instance, if you have a drug of interest that you can search. We'll put chlorpheniramine, and you can select the study type, the population here, and then search on that, which will allow you then to look at the drugs in the various populations. So if I'm only interested in, say, maternal, you can see here that it brings up the 8 studies relating to maternal aspects, and you can then download the data as well.
It's pretty straightforward. Yeah.
And then it gives the, as well, this is what you'll actually see when you first log in, is the overview screen. And you can access this through our MPRINT.org website as well.
And a little bit more info about the database itself. So database itself right now is in the, we'll be actually building a cloud. It's in the cloud right now. So we hope that cloud environment will allow us to be more flexible in terms of its sustainability. I think we purposely did it this year because we feel long-term wise is going to be useful for changes, editing, and I think, you know, for sharing, data sharing as well to some extent. So that's another bit more background information about the database.
Realize no one else can see the link to the Monarch initiative that Aaron shared, so I will put that in the chat so everyone can see that.
All right, any questions from the audience?
See any others? So if not, thank you everyone for joining us. Please reach out if you have any questions regarding the database or improvements we can make for that. Thank you, Lang.
Thank you, everyone. Okay.